In the previous activities, you learned how to read files, handle exceptions, organize your code into modules, and document your work. Now you will take a new step, interacting with the operating system directly from Python. This is a fundamental skill in security automation, because many security tasks involve running system commands, checking file paths, listing directories, or launching external tools such as network scanners. Python provides two essential libraries for this purpose, the OS library and the subprocess library. Each has a distinct role, and knowing when to use one versus the other is critical for writing clean, effective, and secure scripts. The OS library, interacting with the file system and environment. The OS library is a built-in Python library, meaning you do not need to install anything. You simply import it at the top of your script with the line, import OS. The OS library allows your Python script to communicate with the underlying operating system in a portable way, meaning the same code can work on Linux, Windows, and Mac OS without major modifications. Here are the most commonly used functions in the OS library. os.getQuad returns the current working directory as a string. For example, if you run your script from /home/user/projects, this function returns exactly that path. This is useful when you need to know where your script is executing. os.listedRpath returns a list of all files and directories inside the given path. For example, os.listeder/var/log would return a list like syslog, auth.log, kern.log. In a security context, this allows you to enumerate log files before reading them. os.path.exists path returns true if the given path exists on the system, and false otherwise. This is useful before opening a file, to avoid raising a file not found error. You already practiced handling that exception in a previous workshop, and os.path.exists is a complementary prevention tool. os.path.joinDirectory, file name, builds a file path by combining a directory and a file name in a way that is safe across operating systems. For example, os.path.join/var/log, auth.log, returns /var/log/auth.log on Linux. Always prefer this function over manual string concatenation to avoid path errors. os.path.isFile path returns true if the given path is a regular file, not a directory. Similarly, os.path.isDirPath returns true if it is a directory. These checks help validate input before performing file operations. os.environ is a dictionary-like object that holds all the environment variables of the current process. For example, os.environ.getHome returns the home directory of the current user. In security automation, you might store sensitive values like tokens or passwords in environment variables rather than hard-coding them in scripts. os.makeDirsPath, exist_ok equals true, creates a directory and all necessary parent directories. The exist_ok equals true parameter prevents an error if the directory already exists. os.removePath deletes a file. os.remdirPath removes an empty directory. Use these carefully, especially in automated scripts. A practical example. Suppose you want to check whether the file /var/log/auth.log exists before reading it. You would write import os. log_path equals os.path.join/var/log, auth.log if os.path.exists log_path. With open log_path, r, as f. Content equals f.read, else. Print log file not found. This pattern combines skills from your file reading and exception handling activities with the new OS library knowledge. The OS system function, a simple but limited way to run commands. The OS library also includes a function called os.systemCommand that allows you to run a shell command from within Python. For example, os.system/ls/var/log will list files in the /var/log directory, just as if you had typed that command in a terminal. However, os.system has significant limitations. It does not return the output of the command to your Python script. It only returns the exit code, 0 if successful, a non-zero value if it failed. You cannot capture, process, or analyze the output in your script. It opens the door to security vulnerabilities if the command string is built from user input. This is called command injection. Because of these limitations, os.system is considered a basic and outdated approach. For serious automation work, the subprocess library is strongly preferred. The subprocess library, the modern and powerful way. The subprocess library is also built into Python and gives you full control over external processes. You can launch commands, capture their output, handle errors, set timeouts, and more. Import it with import subprocess. The central function of this library is subprocess.run. It accepts a list of arguments representing the command to run, and it returns a completed process object containing the results. Basic usage example. Import subprocess. Result equals subprocess.run ls, la/var/log, capture underscore output equals true, text equals true print result.stdout. In this example, the command is passed as a list, ls, la/var/log. Each part of the command is a separate element of the list. Capture underscore output equals true tells Python to capture both the standard output and the standard error of the command, instead of printing them directly to the terminal. Text equals true means the output will be returned as a string instead of bytes, which is easier to work with. Result.stout contains the standard output of the command, what you would normally see in the terminal. Result.stateerror contains the error output if something went wrong. Result.return code is an integer representing the exit code. 0 means success, any other value typically indicates an error. Another important example relevant to cybersecurity, running an nmap scan from Python. Import subprocess. Result equals subprocess.run nmap, sv, 192.168.1.1, capture underscore output equals true, text equals true if result.return code equals 0. Print result.stout, else. Print scan failed, result.stare. This allows you to integrate command line security tools directly into your Python automation scripts, process their output programmatically, and build automated reporting pipelines. Handling errors with subprocess. You already know how to use try and accept blocks from previous activities. The subprocess library integrates cleanly with this approach. One important parameter is check equals true. When you pass check equals true to subprocess.run, Python will automatically raise a subprocess.called process error exception if the command returns a non-zero exit code. Example. Import subprocess. Try. Result equals subprocess.runcat/etc/shadow, capture underscore output equals true, text equals true, check equals true print result.stout accepts subprocess.called process error as e. Print command failed with exit code, e.return code print error output, e.stateerror. In this example, reading /etc/shadow typically requires root privileges. If the current user does not have permission, the command will fail, the exit code will be non-zero, and the called process error exception will be caught and handled. Another useful parameter is timeout. You can pass timeout equals 10 to subprocess.run to set a maximum number of seconds to wait for the command to finish. If the command takes longer, Python raises a subprocess.timeout expired exception. This is important in automation scripts that must not hang indefinitely. Avoiding security risks. Do not use shell equals true with user input. One of the most critical points to understand about the subprocess library is the shell parameter. When you pass shell equals true, Python sends the command as a string to the system shell, like /bin/sh on Linux. This enables features like pipes and wildcards, but it also introduces a severe security vulnerability called command injection. Example of dangerous code. User underscore input equals input enter a file name, subprocess.runcat plus user underscore input, shell equals true, hash dangerous. If a malicious user enters something like access.log, rmrf/, the shell will interpret the semicolon as a command separator and execute both cataccess.log and rmrf/, potentially destroying the system. The safe approach is always to pass the command as a list without shell equals true. Subprocess.runcat, user underscore input, hash safer. When the command is a list, the arguments are passed directly to the operating system without being interpreted by a shell, which prevents injection attacks. In a cybersecurity context, this distinction is fundamental. You will encounter command injection vulnerabilities in web applications and APIs during penetration testing, and understanding how they work at the system level makes you a better tester and defender. Combining OS and subprocess in a practical script. Here is a more complete example that combines what you have learned. Imagine you are writing a script that automatically scans a list of hosts and saves the results to a report file. Import OS. Import subprocess. Output underscore dir equals scan underscore results. os.makeDirs output underscore dir, exist underscore OK equals true. Hosts equals 192.168.1.1, 192.168.1.2. For host and hosts, output underscore file equals os.path.join output underscore dir, host plus underscore scan.text try. Result equals subprocess.run. Nmap, sv, host. Capture underscore output equals true. Text equals true. Timeout equals 60. Check equals true. With open output underscore file, W, as F. F.write result.stout, print scan saved for, host, except subprocess. Called process error as E. Print scan failed for, host, E.stare except subprocess. Timeout expired. Print scan timed out for, host. This script creates a directory for results, iterates over a list of hosts, runs a network scan on each one, saves the output to a text file, and handles errors gracefully. It uses os.makedirs, os.path.join, subprocess.run with capture underscore output, text mode, timeout, and check, as well as try and accept blocks you already know. Key points to remember. The os library is used for interacting with the file system and environment variables, checking paths, listing directories, building paths safely, and reading environment variables. os.system can run commands but cannot capture their output and is considered outdated for automation. The subprocess library is the modern standard for launching external commands from Python. Subprocess.run is the main function. Use capture underscore output equals true and text equals true to retrieve output as a string. Result.stout contains the standard output, result.stare contains errors, and result.return code indicates success or failure. Use check equals true to automatically raise an exception on command failure, and timeout to prevent scripts from hanging. Never use shell equals true with external or user-provided input, as it creates command injection vulnerabilities. Always pass commands as lists of strings to subprocess.run to avoid shell interpretation. Combining os and subprocess allows you to build complete automation pipelines for security tasks, scanning networks, parsing logs, generating reports, and interacting with external tools.